So is a 1. So we've got something like this. Let's say x squared plus 10x plus 21. All right, so that's the easiest case. So I'll show you how this factors, and then I'm going to back up a second and then show you what I did and why I did it. So what I'm looking for is I'm looking for two numbers that multiply to be this and add up to be that. Not the x, just the 10 part. And so those two numbers are 7 and 3. 7 times 3 is 21. 7 plus 3 is 10. Great. So that means that this factors as x plus 7 times x plus 3. And that is indeed true. And now I think a reasonable question might be, why did how do I know that I'm looking for two things that multiply to be this and add to be that? And I'll show you in just a sec, as soon as we check this. So if I were to remultiply this out, I would get x squared plus 3x. And this is 7x and 21 there, plus 7x plus 21. And so the thing I get is x squared plus 10x plus 21, exactly like I wanted. All right, so that means that my answer is x plus 7, x plus 3, or x plus 3, x plus 7, if you prefer to write it that way, which is totally fine. Does not matter what order you write these in, it's multiplication. You can multiply in whatever order you want. So let me show you why that is what I'm looking for. So I'm going to do this. I'm going to multiply out. So I'm going to go backwards, basically. I'm going to start with two binomials with a coefficient of 1, or a leading coefficient of 1. So I'm going to have x plus, I'm going to write this as a, and x plus b. So in other words, the numbers, sorry, I'm going to redo that. Don't like that plus sign. So the numbers that I'm looking for in the parentheses are a and b, right? I don't know what they are, basically. So here they were 7 and 3, but here I'm not assuming that I know what they are. So let's multiply this out. So we're going to get those two. That's x squared plus bx, and this is ax plus ab, ax plus ab. And then what I'm going to do is I'm going to group these up by power of x. So x squared plus, this is ax plus bx. So what I'm going to do is I'm going to factor the x out and just be left with that. And notice that a plus b is a number, it's a coefficient. You know, let me do this in a couple of steps. I'm trying to talk through this too fast. It'll be a little easier to understand if I go a little slower. So I'm going to write this as this plus ax plus bx plus ab. Now out of these two terms, I'm going to factor the x out. And then the thing I'm going to notice is that a and b are numbers, right? So this a plus b is going to be some number. In the other problem, it would have been a 10, right? Because a and b were 7 and 3. So this I'm going to write it like this: x squared plus a plus bx plus ab. Now, the reason I wanted to show you this is the following. Remember on the last board, I said I'm going to look for two numbers that multiply to be this and add up to be that. Here's why. The two numbers I'm looking for are a and b, right? A is 7, b is 3. So in here, a times b, those two numbers, a and b, multiply to be the constant term, and they add up to be the coefficient of x. That's why I'm looking for those. That's why I'm looking for numbers that multiply to be the constant and add up to be the middle term, or add up to be the coefficient of the middle term, I should say. Is because in the most general case, that's what happens, right? When I multiply this out, that thing is the coefficient of the middle term is the sum of the two numbers I'm looking for, and the constant term is the product of those two. So let's see another one if we can. So let's go do another easy guy. So we got x squared minus 3x minus 10. All right, so now I'm looking for two numbers that multiply to be -10 and add up to be -3. And again, you can probably figure that one out rather quickly, but let me show you the sort of general way to do it. So I've got -10 here, and so what I'm going to do is I'm going to write out all of the products that can multiply to be negative 10. I'm actually just going to do 10, and we'll talk about the signs in just a second. So 10 could either be 1 times 10, or it could be 2 times 5. And that's actually it. That's all of the options. And I want this to be negative 10, so I need one of them to be negative, right? So I could have negative 1 and positive 10, or positive 1 and negative 10. I don't want to write out all those. We'll just think about the signs separately. So I know I need one of my numbers, my A or B, to be negative to make negative 10, and then I need them to add up to negative 3. And so what you want to do is look at this list and ask yourself, how can I make a 3 out of each of these pairs? Like 1 and 10, no adding or subtracting is going to give me 3 there, right? I either get 1 minus 10 or 10 minus 1, and that's 9 or negative 9. It's no good. 2 and 5, though, I can get a negative 3 out of this if I make this negative 5 and positive 2. And so that's what I want to do. I'm going to let my A and B be 2 and negative 5. So I'm going to think of this as x plus 2 times x minus 5. And then just to be sure that I've done that correctly, I'm going to multiply it all out to see that it works out. So I'm going to have x squared minus 5x, so x squared minus 5x plus 2x minus 10, which gives me x squared minus 3x minus 10. So we've got it. So that's the thing to look for. You want to check to see the sign and the size of this number, and then just write out all of the factors of that number. Now, let's do something a little bit messier than that. Let's pick a slightly harder example. So let's say t squared minus 13t minus 30 or plus 30, minus 30. Okay, so this one will be a little bit harder to do. This one is probably not just a complete freebie. This one is a little bit harder to do. And so I'm going to write out all of the factors of 30. So I'm going to narrate what I'm doing while I'm doing it. So 30, I want it to be negative 30. And again, I'll worry about the sign later. So I'm going to start with 1 and ask myself, does 1 go into 30? And of course it does. 1 goes into everything. Does 2 go into 30? Yes, it goes in 15 times. Does 3 go into 30? Yes, it goes in 10 times. Does 4 go into 30? No, not evenly. Does 5 go into 30? Yes, 6 times. And then the next number I would try would be 6, and that's on the other side of the list, so that's how I can tell I'm done. So as soon as the next number you would check to see if it goes in is already in your list, then your list is finished. So this is all of the things that I can multiply out to be 30. Now I need negative 30, so I need something where one of them is negative, and I need them to add up to be negative 13. So when I look through my list, 1 and 30 is not going to give me a 13. 2 and 15 can give me a 13, right? If I do 15 minus 2, that'd be 13. 3 and 10 can also give me a 13. If I do 3 plus 10, that would give me 13. 5 and 6 cannot. They can either give me a 1 or an 11, depending on whether I'm adding or subtracting. So I've got 2 ways to make 13 here. Now, only one of them will work. And the way to figure it out is to look at this sign right here. That sign is telling me I need one thing to be negative and the other one to be positive, so I'm subtracting. Right? So I can't do 10 plus 3 because that would imply that both the signs were the same, right? Plus 3 plus 10 or minus 3 minus 10, neither of which would give me 30, or neither of which would give me the signs that I wanted, right? Those wouldn't give me negative 30. If I did plus 3 plus 10, I'll get plus 30. If I do minus 3 minus 10, I'll get plus 30 again. So it has to be the other one. Sometimes this happens. Now, there will never be more than one that works. Sometimes there will be none that work, but it can never ever be more than one. So even though we can get 13 2 ways, this negative means that only one of those ways is going to work. And the way I want to get minus 13 is minus 15 plus 2. So if I write this as t plus 2 times t minus 15, and if I FOIL that out, t squared minus 15t plus 2t minus 30, so t squared minus 15t was the first thing we got, minus 15t, then plus 2t minus 30 will give me t squared minus 13t minus 30. And just to prove a point, I'm going to go -3, -10, and show you that it doesn't work out. Right? I know it won't work out ahead of I know ahead of time it won't work out, but I will show you why it doesn't. Right? So if I tried t minus 3, t minus 10, we get t squared minus 10t minus 3t minus 3 times minus 10 is plus 30, and that's the thing that doesn't work. Right? So we got t squared minus 13t, and that's good, but then I have plus 30, so that's not the same polynomial, right? This plus down here means that this didn't work. And that'll always happen. This will always be a plus if you have the same signs in here, because we're going to do -3 times -10 gives me plus 30. If I did plus 3 times plus 10, of course, that'd be plus 30 as well. So the thing we wanted was t plus 2, t minus 15. T plus 2, t minus 15, box. All right, great. So that is the easy case. I do want to show you a little bit more of the easy case. So 1 second, I'm going to go ahead and pause the video for 1 second, and I'll be right back. All right, I'm back. It probably didn't seem like any time passed to you. I just needed to line up my next example. I had to work out, make sure it worked. So this is the one I want to do. So this, you might say to yourself, that does not look like the easy case. And it kind of isn't, but it also kind of is in the following sense. Before I do anything else in a factoring problem, the first thing I want to do is ask myself if there's anything I can factor out to make everything smaller, right? You can tell this is hard because the numbers are big. And it gets a lot easier if we can make the numbers smaller. We can do that by factoring out any greatest common factor, or any common factor, but ideally you want to get everything. So the greatest common factor is the one you want. So when I look at this, it turns out that 4 goes into 4, obviously, and 76, and 352. So I can pull a 4 out. I can also pull a y out. So that's what I'm going to do. I'm going to pull out 4y and see where we're at. So when I pull 4y out of 4y squared, the thing I'm left with, or excuse me, out of 4y cubed, the thing I'm left with is a y squared, because that's what I would need to multiply 4y by in order to get 4y cubed. Pull a 4 out of 76, I'm left with 19. I pull a y out of y squared, and I'm left with a y. And then if I pull a 4 out of 352, 4 goes into 35 8 times. And that leaves me 32 left over, and it goes in 8 times that as well. So this is 88, and the y comes out as well. That, in the parentheses, is significantly easier to factor than the original one, right? And this is what I meant by always pull out your greatest common factor. It always makes your life easier. Everything inside is smaller, easier to deal with. So pull out your greatest common factor first every time you're doing a factoring problem, especially if it looks extra messy, like the numbers are extra big. That should like set off alarm bells in your head that, hey, I should be looking for greatest common factor to pull out. Now, you should be thinking that anyway, but especially when the numbers are big, be very, very cognizant of that. So what I'm looking to do now is factor the stuff inside. So I don't care about that 4y anymore. It's just going to sit there in front and not do anything. What I'm looking for is two numbers that multiply to be 88 and add up to be -19. And I'm guessing you've probably already figured it out, but let's go ahead and run through it anyway. So 88, we can have 1 times 88. Does 2 go in? Yes, 44 times. Does 3 go in? No, 3 is not a factor of 88. How about 4? Yeah, 22. 5, no. 6, no. 7, no. 8, yes. 9, no. 10, no. 11, yes, but it's already over there, right? My next number is 11, so that means my list is complete here. Now, I need this to be positive 88, so these things have to be the same sign, either minus minus or plus plus. The fact that this is -19 tells me I need it to be minus minus. So I'm looking for two numbers that can combine to be 19 in here. 1 and 88, no, that's either 89 or 87, depending on adding or subtracting. This is either 42 or 46. This is either 18 or 26. And these guys, if I add them up, I get 19. And so that's the one I wanted. Now I need it to be -8 minus 11 so that I get minus 19. But -8 times -11 is still plus 88, so we should be good here. So this is going to be 4y times y minus 8, y minus 11. Now let's make sure that works out. So I'm going to not worry about the 4y when I'm multiplying this out for just a second. I just want to make sure I got this part right. So we're going to have y squared minus 11y minus 8y plus 88. That looks pretty good to me. That looks like y squared minus 19y plus 88, which is what I wanted. Now, so this looks good. So now what we want to do is check to make sure that if I multiply the 4y back in here, that I would get my original problem, right? So I'm kind of checking in 2 steps. So 4y times y squared is 4y cubed. 4 times 19 is 76. Sign's correct. I got y times y is y squared. And then 4 times 88, well, so 4 times 88, the thing I'm doing here is this. Right, that's how I'm doing this in my head. I'm thinking about 4 times 80 plus 4 times 8. That'll give me 320 plus 32 is 352. So that's what I wanted. No, the y is clearly correct. So yeah, this is what I wanted to do. So pulling out your greatest common factor makes things a lot easier. Now, sometimes you're not in the easy case. Sometimes there's just a coefficient in here which makes things a lot harder. Now, your book will tell you that one thing you can do is try all the possible combinations, and you can. That's just not a great way to do it. What I want to do is show you a methodical way to factor something like that. So let me go ahead and grab an example. Oh yeah, that looks like a good one. So we'll go 6x squared minus 5x plus 4 minus 4. So here's the thing. If I look for 2 numbers that multiply to be -4 and add up to be -5, I will not find them. There are not such numbers. However, this isn't the case that we had back here. I can't factor it like this, like x plus a, x plus b, because I need a 6 in front, right? So it's got to be like x plus a times 6x plus b, or 2x plus a times 3x plus b, or 3 and 2, or 6 and 1, right? And so there's a lot of possibilities to try, and you certainly can. You can absolutely try all of them and see what works out. And your book even has a whole bunch on it. Like I'm not crazy about the way they show you to do it, but it does work. The thing I want to show you is called the AC method. And so the AC method, it's called the AC method for the following reason. I'm thinking of this polynomial as ax squared plus bx plus c. And so the AC is a and c. It's those guys. And so what I'm going to do is I'm going to do a times c. So in this case, a times c equals, well, here I've got a is 6 and c is -4. So AC equals -24. And then what I'm going to do is the same stuff we've been doing. I'm just going to figure out what 2 numbers multiply to be -24 and add up to be -5. So that's what I'm going to do. -24 could be 1 and 24, it could be 2 and 12, or 3 and 8, or 4 and 6, and that's all my choices. I hope it's fairly clear that the one that can give me a 5, right, the thing that I'm looking for, a -5, I should say, is 3 and 8. And that will be -5 if I make the 8 negative and the 3 positive. So that's what I want, is I want +3 and -8, but I'm going to do something different with them. I'm not going to write this as x minus 3 or x plus 3 times x minus 8. That won't work out. So if I do x plus 3 times x minus 8, let's see what happens. I get x squared minus 8x plus 3x minus 24 gives me x squared minus 11, or minus 5x, which is not what I wanted, right? I got the -5, right? That bit's good, but the rest of the polynomial isn't correct. So what I'm going to do instead with this plus 3 and minus 8 is I'm going to split up my negative 5 as plus 3 and minus 8. I'm going to write this negative 5x as plus 3x minus 8x and see what happens. So when I do that, I get 6x squared plus 3x minus 8x minus 4. And the reason I did that is that this polynomial is now guaranteed to factor by grouping. And that's what I'm going to do. So that's what the AC method is. You use A times C to figure out how to split up your middle term so that your polynomial will factor by grouping, and then you factor it by grouping. So I'm gonna put this on the next page. So 6x squared plus 3x minus 8x minus 4. Whoop, nope. Plus, hang on, zoom's not, there we go. 6x squared plus 3x minus 8x minus 4. And I'm going to use grouping on that. And I'm going to group like this. So I'll pull a 3x out of the first two. I will notice that that middle sign is a negative, and so I'm going to write it as plus a minus, right? Plus a negative 8x minus 4. So 3x times x plus 1. And I'm going to pull a negative 4 out to make, I'm sorry, this is 2x plus 1. My bad. I'm going to pull a negative 4 out of this to make the signs match up. All right, so I pull a negative 4 out, and when I pull negative 4 out of negative 8x, I get 2x. Pull negative 4 out of negative 4, I get plus 1. And then the 2x plus 1 is in common, so I'll pull that out, 2x plus 1 times 3x minus 4. And that will give me what I want. So let's FOIL this back out and make sure that it works out. So 2x times 3x, that's 6x squared. 2x times negative 4 is minus 8x. And we got plus 3x minus 4. And so that gives me 6x squared minus 5x minus 4, which is what I wanted. That was the thing I was going for. So that means that the 2x plus 1 times 3x minus 4 is indeed what I wanted for my answer. 2x plus 1 times 3x minus 4. You never have to worry, by the way, about there being a second option that it could factor as. Every polynomial only factors the one way, if at all. Not every polynomial factors, but all the ones that factor only factor the one way. So that is the AC method. The AC method is like trial and error. You still make this chart and find all of your options, but the thing that you do with the option you select is not just jam it into your answer. You have to do a little bit more. You have to split up your middle term like this, and then factor the remaining polynomial by grouping. That's the AC method. So let me tell you a little bit about the AC method. AC method, as you can tell, is a little bit longer than trial and error sometimes. The AC method is basically always medium difficulty, right? None of this was super hard, but it was a little bit long. And so the AC method turns every problem into a medium difficulty factoring problem, which when your problem starts out easy is not so great, right? So you don't really want to use it in that case. But it's fantastic when your factoring problem is really hard, right? Because it takes that hard problem and makes it a medium problem. So use the AC method when your factoring problem is really hard, and not when it's really easy. So this is why I think it's valuable to learn the AC method and also trial and error, because like trial and error on really hard factoring problems is really long and tedious and painful. It's pretty terrible. I cannot recommend it. So when the problem is hard, use the AC method to make it medium. When the problem is easy, use trial and error, because that's usually pretty easy. I want to show you a couple of other cases of factoring these things. So here's a relatively easy case. So I'm going to do x squared minus 16 is the thing I want to factor. Now, I'm looking for two numbers that multiply to be negative 16 and add up to be what now? Well, if I'm thinking of this as ax squared plus bx plus c, then this term is not present, right? I've just got the c and then the ax squared, and a is 1 here. And when a term is not present, that means its coefficient is 0. So what I've got in this case is that b equals 0. So I'm looking for two numbers that multiply to be negative 16 and add up to 0. So those numbers are going to have to be negatives of each other, right? The only way to get two numbers adding up to 0 is if they're the same but opposite signs. So the only choice I really have here is 4 and negative 4, because the only way to get negative 16, like I could, here, I'll do this, 16. That's like the worst 16 I've ever made. 16. 16 could be 1 and 16, or it could be 2 and 8, or it could be 4 and 4. Those are all my options. Clearly, 1 and 16 cannot give me 0. And 2 and 8 cannot give me 0. The only way to get 0 is plus 4 minus 4. So it's a good thing there's that option here. So that's what I want, is I want x plus 4 and x minus 4. This is an example of something called difference of squares, where this guy's a perfect square and this guy's a perfect square. And it always factors as like plus and minus the same thing, right? X plus a, x minus a is what it does. So we're gonna visit that more in the next section, but don't be too scared off if you have a term missing. That just means its coefficient is 0. So let me show you one other one. So let's say I have like x squared plus 6x plus 9. So now I need two numbers that multiply to be 9 and add up to be 6. So 9 could be 1 and 9, or it could be 3 and 3. And I think it's pretty clear that I want 3 and 3 here. So these two things are the same, right? So 3 and 3 are my a and b. So what I have is x plus 3 and x plus 3. And so I would write that as x plus 3 squared, right? It's two things that are the same being multiplied by each other. And so I can just say it's that thing squared. This is called a perfect square trinomial, and they're not that hard to identify, but luckily you don't really have to. The book will ask you to identify, tell if something is a perfect square trinomial, and then factor it this way. And we're going to talk about that more later when we get to solving polynomial equations. But really, nothing materially changes from the factoring. It's just, oh, the threes have to be the same. That's okay. You can just still factor it the same way if you want to. If you happen to notice that this is a perfect square, and I'll show you what the form is for perfect squares in just a second, then great. That makes it easier, but not tons easier. So let me show you what that looks like, and how you can identify something as a perfect square. So if I have, let's say I have x plus a times x plus a, right? The a's are the same, and those two things are the same, so I'm squaring it. So when I multiply this out, I'm going to get x squared plus ax, and then, so that's x squared plus ax, and then this one is also plus ax, and the other one is a squared. So I get x squared plus 2ax plus a squared. So if there is some number, so firstly, you're looking for this thing to be a perfect square. If the square root of this times 2 is that, then you get a perfect square trinomial. So for example, the one I just did, x squared plus 6x plus 9, the square root of 9 is 3, right? So, and then double 3 is 6. So square root of 9 is 3 here. 2 times that is 6. If that happens to crop up in your problem, then there you go. That's then it's a perfect square, and it factors. It factors like x plus something squared, and the something is the a. So perfect square trinomials don't just occur with leading coefficient of 1. Certainly, you could do something like you could have like a 2x plus 5 squared. And so you get a similar pattern. Let me multiply this all out and I'll show you what it looks like. So this is 2x plus 5, 2x plus 5. When I multiply it out, 2x times 2x and 2x times 5 gives me 4x squared plus 10x, and then 10x, 25. So I get this, 4x squared plus 20x plus 25, which is, you know, a little bit messy. So the 20 comes from the square root of this times the square root of this times 2. So if you happen to notice that this is a perfect square and this is a perfect square, then you can take the square root of the 4 and the square root of the 25, get 2 times 5, 2 and 5, multiply those together, get 10, multiply that by 2, and if that happens to be this, then great, it's a perfect square trinomial. If not, if you're just asked to factor something, 4x squared plus 20x plus 25, and you didn't happen to notice that property, just do the AC method, it'll work fine, right? So if you happen to notice that something is a perfect square, great, then feel free to use that property that I was telling you about. If you don't happen to notice, it's not a big deal. You can just factor normally, it'll work fine. And I think that was the last thing I wanted to tell you about factoring trinomials. Yeah, it is. That's all I wanted to say. So practice these. This is one of those skills that if you practice it a bit, gets significantly easier, right? Factoring is it's a practiced skill essentially. So try it out, use the ones in the book, and I will see you guys in the next one when we are going to talk about using special formulas to factor particular kinds of binomials, things with 2 terms. All right, I will see you then.